Today in MT5504 Mathematical Programming, we are in Unit 3 in the IC session, Transportation and Assignment Problems. Up to today, we have seen that via stepping stone method, we can go to the optimal solution. Today, here in this practical also, in this lecture also, we will see one problem solution via the stepping stone method. So let your point be given as, the problem is given as solve following transportation problem. In bracket, I am saying that obtain initial basic feasible solution via northwest corner method and reach to optimal solution using stepping stone method. Okay, this is in bracket. Now, why this is in bracket? I want to use the stepping stone method. Otherwise, in some of the problem, you may directly lead to the optimal solution, and you will not get how to apply the stepping stone method. That's why I am using this. In exam, if you are said, forced to obtain initial basic feasible solution by northwest corner method, then you must have to go via this channel, means obtain initial basic feasible solution via northwest corner method and reach to the optimal solution via stepping stone method. Then you must have to follow that step. Then only you will get marks. Okay, so here that problem is, I am writing in a tabular form. Say it is having three sources A, B, and C, and destinations D1, D2, D3, and D4. The costs are given, the transportation costs are given in this table, that is 4 unit, 6 unit, 8 unit, and 6 unit. Here it is 3 unit, 5 unit, 2 unit, and 5 unit. Here it is 3 unit, 9 unit, 6 unit, and 5 unit. The production at A is 700 units, at production B it is 400, and at C it is 600. At D1 the requirement is 400, at D2 its requirement is 450, at D3 requirement is 350, and at D4 requirement is 500 units. Then to go towards the northwest corner method, first of all you have to write this proper tabular form, larger one, so we can allocate the transportation. A, B, C, D1, D2, D3, D4. Units are 4, 6, 8, 6, 3, 5, 2, 5, 3, 9, 6, 5, 700, 400, 600, 400, 450, 350, and 500. So for the northwest corner method, we have to start with the first cell, that is this one, whatever is the minimum from their requirement and the availability, that is 400 and 700, that's minimum is 400, so I will allocate the 400 units here. So here I am left with 0. So this row is this column is cancelled. Here we are left with 300 units. Now northwest corner is this one, so we will allocate whatever maximum is possible there. So here minimum of 300 and 450 is 300, so I am writing 300 here. Here it is 0 and here we are left with 150. So since this is 0, this is cancelled. Now the northwest corner is this one, minimum of 150 and 400, it is 150. So here 150. Here we are left with 0 and here we are left with 250. Now at northwest corner is 0, this because this is cancelled. So here minimum of 350 and 250 is 250. So here we are having left with 0 and here we are left with 150. Now northwest corner is this one, so minimum of 600 and 150, sorry 250, so it is 100, sorry. So minimum of 100 and 600, it is 100, so here it is 100 and here we are left with 0, here we are left with 500, so last corner is 500 with 500, so it is 500 there, both are cancelled directly with 0. So this is our solution via northwest corner method. Now as I know that we have to form a loop several times, so I am making a copy of this table, and since the demand and supplies are not a part of our requirement, so I am not copying that. And here I am pasting it. Okay, now this is transformed, so better me. Here, first of all, observe that what is the transportation cost. Okay, so that is 400 times 4 plus 300 times 6 plus 150 times 5 plus 250 times 2 plus 100 times 6 plus 500 times 5. That is 1600, 1800, 750, 500, 600, 2500. So the net sum is 7750. Okay. Now we start with the stepping stone method. So I already have pasted the table, so we can reduce the time. So now I think to allocate from here, means transport from A to D3. So in that case, the loop will be from here if we want to add, then from here to here, here to here, here to here, and from here to the original point back. In that case, the transportation cost here, we are adding something, so plus here we will subtract, then here we will add, and here we will subtract. So the additional transportation cost is 8 minus 2 plus 5 minus 6. That is 6 minus 6, it is 0, and plus 5, so it is 5. So additional transportation cost in transporting from this point A to D3 is add extra plus 5. So we will not go for that. Now think about to transport from this point. Then in that case, here from this we are transporting. So here the only possibility is to go this point, then from here we are able to go to this point, then here, and move to back. In that case, here we are transporting extra, so here it will be plus, so we have to subtract from here, then we have to plus, add here, subtract here, add here, and subtract here. So the additional transportation cost on transporting from A to D4 is 6 minus 5, then plus 6 minus 2 plus 5 minus 6. So 6 and 6 is cancelled, minus 5 and 5 is cancelled, so here it is 4. So also here we are getting the extra cost, so we will not transport from that point. So better to think about the another. Now let's go to this point. If we transport from this point, then we are having loop is from here to here and then to back. So here we are adding something. So we are subtracting here, adding here and subtracting here. So from B to D1, the corresponding additional transportation cost is plus 3 from here. So it is 3 minus 5 plus 6 minus 4. So here it is minus 2 uh, plus 2, that is 0. So we are not getting any extra cost, but as a whole, we will get the same transportation cost. So we are not thinking about that also. Now let's move towards the another, means this point from B to D4. The additional transportation cost, first of all find out the loop. So here to here, then here and the back. So in this case, the additional transportation cost, first of all we are adding something, so here plus, here it will be minus, here it will be plus and here it will be minus. So 5 minus 5 plus 6 minus 2, so it is 4. So additional transportation cost is 4, so we cannot transport from this point. So that is also not valid to do a transportation. Let's move towards the another, that is from C to A, C to D4. So the corresponding additional transportation cost, for that we have to think about the loop. So from here to possible only is here, from here, then here, and then here, and move towards the back. So here we will have additional transportation cost. So here it will be minus, so here plus, minus, plus, and minus. So the additional transportation cost is 3 minus 4 plus 6 minus 5 plus 2 minus 6. Okay, 3 minus 4 plus 6 minus 5 plus 2 minus 6. So 3 minus 4 it is minus 1 plus 6 minus 6 is cancelled, and minus 5 plus 2 it is minus 3. So here we are having minus 4. So additional transportation cost is reduced, means we will get 4 rupees profit on transporting 1 unit. Okay, so we will think about transporting from C to D4. Okay, but before that, let me check this last point. So this point. So if we want to transport from this point, we are having loop like this, from here to here, here to here, here to here, and then come back. In that case, the additional transportation cost will be here, and then we are subtracting, here adding and subtracting. So from C to D2, the additional transportation cost is 9 minus 6 plus 2 minus 5. That is, here it is 3 minus 3, so it is 0. So here also we are not getting any extra benefit, so we are not keeping this point. So as previously we have seen that transporting from this point is better case for us. So what is the maximum possible transportation from C to D1? That is, from the negative coordinates we have to select the minimum. So here it is 400, it is 150 and 100, so minimum is 100. So we will transport that much unit to the other places. So from 100, we will transport from 100 from here. So if we are adding 100 here, we will subtract 100 here. So it will be next, in next case it will be 0. Since this is 0, to make the sum 350, we will add here 100. So we will have 350 here. Here it will be 150. So we are subtracting 100 units. So here we will have left with 50 units to continue the row sum and column sum same. Then since we have subtracted 100 unit here, we are adding 100 unit here. So it will be 300 to convert it to 400 units. And since this is 400 unit, to continue the column row sum same, we will subtract 100 unit here, and this will be converted into 300 units. So the next, our table, after applying this all changes, table will look like, let me draw table here, and then I will transport means cut paste to another place. Okay. A, B, C, D1, D2, D3, D4. Let me write first of all the cost, that's is same. So 4, 6, 8, 6, 3, 5, 2, 5, 3, 9, 6, 5. And the new entries for the allocations are, here it is now 300, here it is now 400, here it is now 50, here it is now 350. This is cancelled, so 0, so we are not writing there. Here we are having an additional 100, and here we are having 500. Okay, so now I am moving this to the end. So I am cutting this table to the end. So this is our table, and now again we have to check that if for each and every case we are having the same answer, that is this is optimal solution or not. That again we have to check that by stepping stone method. Okay, so let me do that. First of all, I am pasting that multiple times so we can use whenever we are doing. So here, now let me continue with the same methods. So, let me transport from A to D3, and we will check that additional transportation cost is in negative for any points or not. So again we will form a loop. So your loop from here to here, here to here, and here to here. So here it will be plus, minus, plus, minus. So additional transportation cost is 8 minus 2 plus 5 minus 6. So 8 minus 6, it is 2, and minus 2, it is 0, and 5. So here it will be 5. So transporting from A to D3 is not a good choice. Here means A to D4. In that case, let me continue, means find out the loop. So from here to here, here to here, here to here, and from here to here. So here we are adding, here we are subtracting, here we are adding, here we are subtracting. So additional transportation cost in this case is 6 minus 5 plus 3 minus 4. So here it is 1, and here it is minus 1, so 0. So we are not able to reduce the transportation cost further, so we will not use that A to D4 case. Let B to D1. So here we are having loop is like this. So here plus, minus, plus, minus. So that is B to additional transportation cost on B to D1 is 3 minus 4 plus 6 minus 5. So 3 minus 4 is minus 1, 6 minus 5 it is 1. So here we are having additional transportation cost be 0. So also we are not getting the another solution. Means we cannot reduce the transportation cost, so we are not transporting from B to D1. Let's do the similar for B to D4. So for B to D4, the case we are having being the loop is from here we are going towards here, then here, from here, 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 and come back. So here it will be plus, minus, plus, minus, plus, and minus. So additional transportation cost on transporting from B to D4 is here plus 5. So 5 minus 5 plus 3 minus 4 plus 6 minus 5. So that is my 5 minus 5 is 0, 3 minus what it is minus 1, and 6 minus 5 it is 1, so it is 0. So we are not able to reduce the transportation cost further on doing transporting from B to D4. Now let's think about C to D2. So here we are having loop as, here we are having multiple choice, so be careful. Okay, from here to here, here to here, here to here. Loop will be unique always. Okay, so here it is plus, minus, plus, minus. If you will go to this, then you will not have any choice to go further. So that's why I have reached it to this case. So additional transportation cost on this choice is plus 9, minus 3, plus 4, minus 6. It is 6 minus 2, so it is 4. So we are not able to reduce our transportation cost further. So let's move towards the last situation, that is C to D3. In that case, the loop is from here. Again, if I will go here, I will not able to go anywhere else. So I am going towards here, 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 and come back. So here we are having plus, minus, plus, minus, plus, and minus. So additional transportation cost is here it is 6 minus 3 plus 4 minus 6 plus 5 minus 2. That is 6 minus 3, it is 3, 4 minus 6 is minus 2, and here it is 3. So we are having 4. So additional transportation cost is positive. Means for any choice we are not able to find out the negative transportation cost, means we are not able to reduce the transportation cost further. So this is our final choice, means this allocation will give you the minimum transportation cost. Okay, and the corresponding transportation cost, let me check, that is 300 times 4 plus 400 times 6 plus 50 times 5 is 50, okay, plus 350 times 2 plus 100 times, it is 100 times 3 plus 500 times 5 is 1200 plus 2400 plus 250 plus 700 plus 300 plus 2500 is equals to 7350. Previously, the transportation cost was 7700, and we have transported that 100 units at the cost less minus 4. So via that, here minus 4 was the transportation cost reduction, and we have transported 100 units. So we have reduced the 4 times 100, that is 400 units in the transportation cost, and the final solution is 7350. Okay, so here again I am saying that try similar problems at your home and stay at home, stay safe. Thank you.